The last little bit that we're going to talk about in step 14 has to do with evaluating functions and polynomials for various values. Sometimes the values will be numbers, sometimes the values will be variables, and then finally we're going to practice sketching. To start the first problem, we've actually done a lot of these in previous steps this year. Notice that we start with g of x equals 0.5x squared minus 5x plus 3. We take out the x and put in 2.8. And we're going to do that all the way across this entire problem. We're going to rewrite it just how we see it, but whenever we get to an x, we're going to take out the x and put in 2.8. And then finally, we just use our calculator to evaluate this. We type it into the calculator just as we see it and find our answer. As you can see, I've opened up my calculator. I've typed it in just exactly as I have it written on my paper. My answer is negative 7.08. Sometimes when we're evaluating, we're not going to be able to use the calculator because we're going to be inserting a variable. But just like we started before, we're going to simply rewrite g of x, but every time I get to an x, I'm going to insert parentheses, and I'm going to replace that x value with, in this case, 4a. Sometimes I like to write the whole thing first, and now I'm going to go back with 4a. And we simplify. 0.5, 4 squared, a squared gives me 16, a squared. 5 times 4 makes 20, a plus 3. Further simplifying, I get 8a squared minus 20a plus 3, and that's all the further I can go. So g of 4a is 8a squared minus 20a plus 3. Let's try a real challenging one, shall we? Here we want to take this function, I'm going to highlight it, this function f of x, and we want to substitute several things. We want to figure out what f of c would equal. We want to figure out what f of 3c minus 4 would equal. And then finally, we're going to take those answers, multiply the first answer by 5, and subtract it from the second answer. So let's start little by little. First, I'm going to find f of c. And again, I'm going to rewrite this function, but everywhere I see an x, I'm going to replace it with a set of parentheses. And now I'm going to substitute c everywhere that I have that. And when I simplify, I get c squared plus 2c minus 3. That takes care of f of c. Next, I'm going to compute f of 3c minus 4. So again, I'm going to rewrite my expression, but I'm going to replace my x value with 3c minus 4. Now, to simplify this first piece right here, this binomial squared, we either need to box or FOIL. So you could take it out into your margin here, if that helps. 3c minus 4 times 3c minus 4 gives me 9c squared minus 12c plus 16. So just this portion here ends up being 9c squared minus 24c plus 16. This next little bit, we just need to distribute. And when we do that, we get plus 6c minus 8. And then finally the minus 3 just comes down. Further simplifying, we can combine some like terms. Nothing combines with 9c squared, but I can combine my negative 24c plus 6c and get negative 18c. And then I can also combine my 16, negative 8, and negative 3. That gives me 5. But we're not quite finished, because if you recall, the original problem said take f of 3c minus 4, subtract 5 times f of c. This is f of c, and this is f of 3c minus 4. So substituting, I get 9c squared minus 18c plus 5 minus 5 times f of c, which is c squared plus 2c minus 3. Distributing, we have 9c squared minus 18c plus 5 minus 5c squared minus 10c plus 15. Combining our like terms, if I put my c squareds together, I have 4c squared. Negative 18c and negative 10c gives me negative 28c. And finally, 5 and 15 makes 20. So that ends up being my final answer after all of that work. Sketching graphs of functions. So now I've listed out many of the key characteristics in the vocabulary that we've covered in the previous videos for step 14. I've put them all here so that they're right at your fingertips. You won't have to scroll up as much as we begin using all that we've learned to try to sketch a graph given some clues. The first clue that we are given here is that the y-intercept is negative 3. So when I sketch my graph, I know that I want my y-intercept to be at negative 3. So I'm going to put a point. The next little bit of information that they give me is that the function is positive for x greater than 1.5. Again, if you forget what that means, look up here. A function is positive if on a portion of its domain where the graph is above the x-axis. That's the one where I said think of it as above the water. So when x is bigger than 1.5, this graph is going to be above the x-axis. So here's 1.5, so it's up here somewhere. And before 1.5, it's below the x-axis. So I'm going to keep 1.5 marked here. Then they tell me that the function is increasing for all values of x. Increasing means going uphill for all values of x. That means it never has a turning point where it turns down, goes back up again. It's constantly increasing for all values, like a straight line. Then they tell me that the domain is between -2 and 3. And finally, I know that the range is between -7 and -3. All right, so what's this going to look like? Well, I know this is a y-intercept. I know that it's going to cross from negative to positive right here. So next I'm going to just draw a straight line through my y-intercept and through 1.5. Because I know that's the point where it changes from negative to positive. I know that for all values of x greater than 1.5, it's positive. All right, it's increasing for all values of x. It's still going uphill. Next, I need to take a look at the fact that the domain is between -2 and 3. So I'm going to grab my eraser. X equals -2 is right here. That means I need to chop some of this off. There we go. And 3, x equals 3 is right here, so I need to shorten this a little bit. This means that my domain goes from -2 to 3. And then finally it says the range is from -7 to 3, which it is. So I've successfully come up with a picture based on these 5 clues. Let's try another one. The y-intercept is 2. I'm going to put a point right here. It's my first piece of information. The y-intercept is 2. The next piece of information is that the function is negative or x is less than -1. That means that when x is -1, it's going to cross over. Over here it's negative, and then it becomes positive. And when x is greater than 4, so right here, my graph is down in the bottom again. That's where it's going to be negative. Between 1 and 4, it's going to be up here somewhere. I don't know where yet. And again, we're just sketching right now. The function has a maximum at 3, 3. 3, 3 is a maximum. It means it comes up this way and then goes right back down. Now, I don't know if it bends this direction or what it does. Again, it's just a sketch, so let's see. We try to make it as smooth and continuous as possible. Does this satisfy all of the clues? The y-intercept is 2. It has a maximum at 3, 3. The function is negative when x is less than -1 and when x is greater than 4. So it satisfies all the clues. Okay, we're ready for our last example. This function is symmetric about the line x equals 2. That means there's an invisible line right here at x equals 2 that if I folded this graph, the graph would line up right on top of itself. The function has a minimum. Another clue, the function has a minimum and an x-intercept at x equals 2. So a minimum right here at x equals 2, that's also an x-intercept. That's a minimum, so I know it goes up from here. And as x approaches infinity, y approaches infinity. As x approaches -infinity, y approaches infinity. So I have a few options. One option is to graph it like this. Notice it's symmetric about this line. But I could have graphed it like this. Unless they give me more clues, we don't know exactly how wide to make this graph, and that's okay. We're just sketching graphs right now. We are not precisely graphing anything at this point. So any of those answers would be acceptable, assuming that you did a nice job making sure to take your time to make sure they're symmetric about the line x equals 2.